All right, welcome. In this video, we're going to be working Algebra 2 Homework 11.3, which is mostly about functions that are defined in pieces, but also we're going to start getting you reviewing how to find an inverse function, kind of getting towards that test coming up. So we're going to write a piecewise defined function for all four of these graphs. So what we're going to do is we're going to say, all right, f of x equals, I see two different things going on. So I'm going to write this as, okay, well, it looks like x, or f is always equal to 1 when x is greater than 0. See, that open circle means we say y is 1 when x is greater than 0. And y is negative 1 when x is less than 0. And then for b, I've got two lines, so I'll have to maybe be a little more careful. This has got a slope of 1/3 and a y-intercept of 1, so 1/3 x plus 1 when x is less than or equal to 0. Okay, we could probably, either one of these could be less than or equal to or greater than or equal to. Probably both of them could since it's going to the same point, but I'm just going to only choose one. But it doesn't really matter which one because we have this shared point there. When we go plug in 0 here, we're going to get 1, and for this one, we had better be getting 1 if we plug in 0 as well. Okay, so for this one, I've got a slope of -½ and a y-intercept of 1. For C, this is looking like, this looks like a standard parabola, 2, 4, 1, 1, 0, 0. So I'm thinking y equals x squared. Always, except for at x equals 1. So this is x squared when x is not 1. And then it's equal to 3 when x is equal to 1. Okay, so that's the type of thing that we need to know about as well, that we might have a piecewise defined function where we're defining it on intervals, but we could also have everything except for one point and then replacing it elsewhere. Okay. D, this is looking like a line with slope 1 and y-intercept 1, so y equals x plus 1. Y equals x plus 1 when x is less than or equal to 1, because I've got a filled in circle here. So x less than or equal to 1. And then this looks like a square root curve. Okay, so let me think. The hypothesis would be square root of x minus 1, just like square root, but shifted right by 1. Okay, and square root, okay, over 1, up 1, yeah, that seems right, because if it was the square root of x minus 1 and I plugged in 2, I'd be taking the square root of 1, and that's 1. Okay. And 5, 2, yeah, that looks right also. Okay, so I'm going to say square root of x minus 1 when x is greater than 1. And greater than 1 because of the open circle there. Okay. Number 2 is going to ask us to sketch some graphs. Okay. And this does not have to be anything super special. I don't need you to do this on graph paper or anything. I'm going to say, all right, 2 to the x, that's exponential growth. And 2 minus x. All right, so we're going to go, and it's going to go up like that until x is equal to 1. X is less than or equal to 1. So I'm just going to put that there and like that. That's 1. And then 2 minus x when x is bigger than 1. Okay, the y-coordinate of this is going to be 2, and that's going to be important to us because, okay, when x is equal to 1, on this next piece on the line, the y-coordinate would be 2 minus 1, which is 1. Now, this is not on the graph because we're only following that rule when x is bigger than 1. So we put in the open circle, but the actual coordinate of the open circle is going to be what I would get when I plug in 1 there. So it's going to -1 slope, and that's going to be my graph. Okay, for g of x, I've got cube root of x. Okay, we know cube root would look like that, but only when x is less than 0. So we're going to put in a nice open circle there. Give the first half of cube root x. And then for x greater than or equal to 0, y is going to equal 1. So always like that. For C, h of x is natural log x when x is positive. Okay. Remember, natural log x is the one with a vertical asymptote at the y-axis, and then it really levels off. And that's all x greater, x greater than 0. X less than 0, that would be undefined. That wouldn't make any sense. And x to the fourth, when x is less than or equal to 0, well, that looks like a parabola, but with, it's a little bit more dramatic towards the middle. So maybe I'll draw it like that. And that'll be my sketch. For D, it's y equals 1 over x as long as x is not 2. Okay, so I'm just going to decide where 2 is. Okay, I'm going to have to put an open circle there because we're excluding that value. And the other half of y equals 1 over x will be unchanged. And then the y coordinate that I'm going to fill in instead of 1 over 2, I guess, is going to be y equals 3. So I'm just going to decide where I want 3 to be, and I'm going to fill in a circle right there. Okay. So I've got 2 more. Just do that. So 2e is going to be absolute value of x plus 1. Okay. The absolute value of x looks like a v, and knowing what we learned recently, okay, this is going to be like the absolute value of x, but shifted left by 1. So I'm going to have v like that, and it only goes when x is less than 1. So 1, 2, whoops, yeah, there we go. And again, I know that y coordinate is 2 because if I plug in x equals 1, I take the absolute value of 2. That's 2. All right, and then x minus 1 when x is greater than or equal to 1. Okay, if I plugged in 1, I'd get 0 here. So it's filled in circle because greater than or equal to, and then a slope of 1 should be about parallel to that part, but that's what that graph's going to look like. And then 2f has got 3 pieces. Okay, so it's got line, line, line. Okay, am I going to need... I don't feel like I'm going to need a whole lot of negative y here. All right, so negative 2x minus 2 on the interval negative infinity to negative 1. Glad I did that, because you will see this occasionally where the rule is written in interval notation, or the domain for each rule. And so negative 2x minus 2, all right, when x is negative 1, I'd have positive 2 minus 2 is 0. So x is negative 1, that's supposed to be an open circle. And it's got a slope of negative 2, so maybe I'll just say, about like that. And then y equals x plus 1 at negative 1. Okay, that would be negative 1 plus 1 is 0. Oh, hey, okay, so it's going to be a filled-in circle. Function is going to be continuous at that spot. That's something that we said. X plus 1 is a slope of regular 1, so we're just going to go in there until x equals positive 1. And then it's going to be 2. Okay, but that's kind of what we're getting towards here with x plus 1 as we're approaching 1. So it's going to just have an open circle there because it was less than 1. But then, oh, wait a second. Okay, we are excluding x equals 1 from the domain. So I'm glad I caught that. So that's going to stay open. And that's us sketching some graphs of piecewise functions. Okay. Number 3, we're going to find the value of k that makes the function continuous at all x. And this is a problem type that we need to be familiar with because we solve it the same way every time. This is an AP calculus problem type, but I figured it was related to what we're studying right now, and it's right at y'all's level. So what we're going to do is if we want it to be continuous, we need the 2 pieces of graph to meet up at the point that they would be splitting at. Okay, so I need x squared to equal x plus k. At x equals 5. So I'm going to plug in x equals 5 and solve for k. So 25 equals 5 plus k. That means k is going to equal. For b, I need log base 2 of x to equal x plus k divided by x minus 2 at the point where x is equal to 1. So I'm going to need log base 2 of 1 equaling k plus 1. Whoops, that was supposed to be an x minus 2. I got ahead of myself. K plus 1 over 1 minus 2 is negative 1. Yes, great. All right, now, log base 2 of 1, that's the exponent I put on 2 to get 1. That's going to be 0. So 0 equals k plus 1 over negative 1. I can multiply both sides by negative 1. 0 times negative 1 is still 0. Or I could have thought about it the only way a fraction is going to be 0 is if its top is 0. Either way, we're going to get k equals negative 1. Then for c, I'm going to say, all right, the square root of 2x plus 3, that needs to be equal to the cube root of x minus k at, oh no, that's not good. Hold on, that's a typo. That's not what's supposed to happen. There's no value of k that would make that continuous as it's written, right? Because there's going to be a huge gap between 1 and 3. And x greater than 1, x less than or equal to 3, that doesn't make sense. Let me think about this. All right, yes, that definitely needs to be a 3 there. So this is going to be at x equals 3. So I'm going to plug in 3. 2 times 3 is 6, add 3 more is the square root of 9. That's going to be positive 3. Equals the cubed root of 3 minus k. Okay. So the square root of 9 is equal to 3, equals the cube root of 3 minus k. And this is the type of equation we've learned how to solve in this class. We're going to take both sides to the third power to get rid of the cube root. So 3 to the third is 27. That's going to equal 3 minus k. And maybe I'll subtract 3 over here, and I get 24 equals negative k, so k is going to equal negative 24. Okay, with number 4, we're going to be kind of getting in on starting to review a little bit. So we're going to compute f inverse of x. So I've got y equals 5x minus 2 over 2x plus 14. And that's, okay, yeah, this will be fine. We can do this. We're going to solve for x. So what we're going to do is, I guess, we're going to have to multiply both sides by 2x plus 14. So y times 2x plus 14 equals 5x minus 2. And then I'm going to distribute the y. 2xy plus 14y equals 5x minus 2. And now, I don't feel like I showed you how to do this one, but if we're trying to solve for x, just get all of the x's onto one side of the equation, and then we'll factor it out and then divide away whatever we're left with. So this doesn't have x in it, so I'm going to move it over to the other side. I'm going to subtract 14y from both sides, and 5x, I guess. And then I can factor an x out of this, and I'll be left with 2y minus 5. And then I can solve for x by dividing both sides by 2y minus 5, negative 14y minus 2, divide by 2y minus 5. And although I can factor out a negative 2 from the numerator, I can't factor a 2 from the denominator, so I don't see any real path to simplification here. And so I'm going to say f inverse of x equals negative 14x minus 2. I'm just going to kind of switch x and y over 2x minus 5. And yeah, I think that's all I've got to say about this. I am going to ask you to compute the inverse of a rational function on the test, but it's not going to be one like this where it's linear over linear. It's going to be a little bit easier, and I'll make sure to have one like exactly like it on the review. Okay. So for 4b, I'm going to be finding the inverse of x squared minus 8x plus 16. Now with these, we have to complete the square. We have to be able to like write it as x minus a number squared, maybe plus some other number, which I think is what's going to happen in C. And then we'll take like a square root of both sides. This is the only way we're going to be able to solve for x. Okay, aside from using the quadratic formula, but that you have to set it to 0 and you'd have to subtract that y over there. And I really don't think that's the way to go. You can. If you want to use the quadratic formula, you can, but I'm not going to be showing you how to do that in this video. What I'm going to do instead is factor the right side and be like, wait a second, this is already a perfect square. So this is x minus 4 squared, because two numbers that multiply to 16 and add to negative 8, that would be negative 4 and negative 4. And then I can just solve for x. I'm going to start by taking the square root of both sides of the equation. So I'll have plus or minus the square root of y equals x minus 4. And I could add 4 to both sides to solve for x on its own. And I'd have 4 plus or minus the square root of y. Okay, that's a rule for the inverse, but if I need f inverse of x, that's going to be 4 plus or minus the square root of x. Yeah, that's good there. C. This one, you know, if you tried to like factor out the x, which I think is probably what without help, most of y'all would try to do, you still couldn't really solve for x. Got to have x and an x minus 6, and how am I supposed to just solve for x right there? That's going to be hard. So what we're going to do instead is we're going to complete the square. So y equals 4c, x squared minus 6x. And what I need to do is add the same number to both sides to make this a perfect square trinomial. And I know it's been a really long time, but starting to review for the final exam too, I need to remember how do I complete the square. So what I do is I take the negative 6, I divide it in half, that would be negative 3, and then I'll square negative 3. So what I'm going to need to add to both sides is going to be a 9. So I'm going to say, all right, I'm going to just add it to both sides. Add 9 here, and I'm going to add 9 there. And then this is going to be factorable. Okay, it's the same equation, right, because I added the same thing to both sides. I'll have y plus 9 equals x minus 3 squared. That number that we ended up squaring, well, that's going to be the number in here. Okay, or you could think of two numbers that multiply to 9 and add negative 6, negative 3, and negative 3, however you like it. So I'm going to solve for x by taking the square root of both sides. I'll have plus or minus the square root of y plus 9 equals x minus 3. And much like the previous example, I'll solve for x by adding 3 to both sides. So x equals 3 plus or minus the square root of y plus 9. Oh, but it asks for f inverse of x. So I'm going to switch x and y and say this is 3 plus or minus the square root of x plus 9. That's great. And then D, oh, this is one, okay, I'm really glad I put this on here because this is a type of inverse that we haven't solved yet. We have dealt with fraction exponents in this class. So this will be good that we're doing this. So if I have y equals x minus 1 to the 3 halves. We solved equations like this where this was just some number, probably some number I could take to the 2/3 power. And then we just took both sides to the reciprocal power. So that's what I'm going to do here. I'm going to say y to the 2/3 is equal to x minus 1 to the 3 halves. And I'm just doing this to remind you of why this is valid to the 2/3. And then, power of power, I'm going to multiply these two exponents. And since I took the reciprocal power, this is going to multiply to 1. I got 6 over 6, right? So I've got y to the 2/3 equals x minus 1 to the first power. Well, that's just x minus 1. I'll solve for x by adding 1 to both sides, 1 plus y to the 2/3. And as a result, f inverse of x would equal 1 plus x to the 2/3 power. Okay, that's a good one. I like that one. Now this last one, I like this one because it forces you to solve a system of equations. So let's find the values of a and b that make the function continuous at all x. So what we're going to do is kind of like the ones on number 3, we're going to need to set the pieces equal to each other and plug in the x value they share. So there's two places where I could be discontinuous here, so I'm going to have two equations that need to be true, and that's going to, with a and b, two unknowns, two equations, that's a 2x2 system. So what I'm going to say is I need x plus 5 to equal ax plus b at the point where x equals negative 1. And I'm also going to need ax plus b to equal x minus 7 at the point where x equals 2. So I'll plug in my x value, negative 1 plus 5, that'll be 4, equals negative 1a plus b. And then when I plug in x equals 2, I'll have 2a plus b equals 2 minus 7 is negative 5. That's going to be my system. So okay, I'm thinking this is looking pretty good for elimination. I could double this and add down, or I could multiply by negative 1 to kill off the b's. I don't think it really much matters. I'm going to double the bottom equation. So I'm going to say 2a plus b equals negative 5, and negative 2a plus 2b equals, double both sides, that's going to be 8. Now I add this together, get 3b equals 8 minus 5 is 3. That's telling me b equals 1. And then I go to the easier looking of the two equations, probably this one, negative a plus b equals 4. So negative a plus 1 equals 4. That means negative a equals 3. I'm going to say b equals 1, a equals, can't see that, and I'm going to say -3. And that'll be my answer. All right, that's all the problems on this homework. Thanks for watching. Hope this helped.